Okay, as usual, right on the dot. We are here again this Friday afternoon to spend some time together. Welcome. Hello, everybody. Welcome back to those joining us for the second, third, fourth, fifth, or even sixth time, as this is the final session of our training series dedicated to turning biodiversity observations into insights. I'm Christina. I will be your host today for the next 90 minutes or so. And we do have planned something special for this Friday, introducing you to the b3verse, which is a suite of R packages that are used to explore occurrence cubes and calculate indicators. And with us to guide us through this b3verse are three amazing people, Shawn, Ward, and Jasmine. So big thank you to them for accepting our invitation and joining us this afternoon, and also sharing their experience with us. So what we are going to do is to have an introduction in the topic, then hands-on sessions, a practical case study presentation, and as usual, please do use the Q&A option to ask questions, and we will try our best to answer them as soon as possible. So that would be the plan for the day. In case this is your first time joining us, this training series is organized in the framework of the B-Cube project, which is funded by the Horizon Europe Research and Innovation Program, and is aiming at standardizing biodiversity data to improve policy making. You can find out more information about the project's aims and outputs on the website, which is bcubed.eu, and you'll find out more about the interesting things that are happening. The project is coordinated by Quentin Groom from Meise Botanic Garden, Belgium. He's the leader of a big team of fantastic people, which are based in Europe and beyond European borders. So we do have a lot of things going on in the project. As mentioned, this is our surprisingly last session of the training series. We did start this series a few weeks ago, and we have been meeting regularly on Fridays at 3 o'clock on the dot. In case you missed our previous sessions, you can find the recordings and slides and other useful materials on the bcube.eu website under the section news. So please do take some time to check out what we discussed previously. We had some amazing talks given by amazing people on species occurrence cubes, biological invasions, indicators, maps, and different kind of maps, actually. And today we are here talking about the b3verse. Just before I hand over to our amazing speakers today, let me just tell you a couple of things about them. Shawn, he's a postdoctoral researcher at Justus Liebig University in Germany, and he is into development of software tools and workflows for biodiversity conservation, and he has a lot of experience with biodiversity indicators and analysis of biodiversity trends. Ward, he's a statistical expert at the Research Institute for Nature and Forest in Belgium, also known as INBO, and he is focused on his research is focused on monitoring scheme, data analysis. He's passionate about this reproducible research, and he's your go-to guy in case you are a researcher in need for support with your statistical analysis. And also, we have with us Jasmine, and she's also working at the Research Institute for Nature and Forest in Belgium, where she's focusing her current research on the management of invasive species. She's the manager of Vespa Watch, which is a platform that they are using to monitor the spread of the Asian hornet in Flanders using citizen science. And she's also very experienced with spatial modeling of population and community dynamics. And these are just a few of the things that these amazing people are good at. Just before I hand over to them, for today's session, we do have a poll. So we kindly ask you to answer these questions. And since this is the last session of the series, we do have a bonus question. So 4 questions today. The first one, but they are really simple questions, but please do take the time to answer them, as it will help us a lot to organize future trainings and who knows what else. So the first question is about the country that you're based in. And the second question relates to the stage you're at in your careers. The third question is about the main sector in which you currently perform to your activities. And the fourth question is, have you attended any of our previous training session within this training series? So if there's interest, perhaps we will organize some other events as well, and we'll invite you. Please do take a couple of minutes to answer these questions. Okay. Let's see. We have students, undergraduate students and master students that joined in this Friday also, a couple of PhD candidates, and also early career researchers, so postdoctoral researchers, early career professionals, mid-career professionals, and a couple of people with more experience, more than 10 years experience. So we do have a good distribution of participants joining in with different levels of experience. So that's good. And not surprisingly, more than half of our participants are people that are active in academia or research institutes. But also, we have people joining in that work in governments, public administration, NGOs, private sector, and consultancy. Okay, so half of the participants are here the second, third, fourth time, maybe. So they attended some, but not all sessions. And we have roughly 11% of participants joining in for the first time. That's also very nice. Check out our website for the previous sessions. Maybe there's something interesting for you there as well. And a third of the participants have attended all previous sessions. Thank you for your joining in each week. I think we had fun and we also learned a lot in the past weeks. It's a nice way to spend your Friday afternoons. Okay, thank you for your answers. And now I think I can hand over to our trainers. Thanks again for your time. Over to you.
Okay, thank you, Christina. I will share my screen. All right. Thank you, everyone, for joining us today, and welcome. So Today I will talk together with Shawn and Jasmijn about the b3verse, which is a collection of R packages that can be used to look at occurrence cubes, to analyze them, to process them, to visualize them. But before we do that, I first want to make sure that everyone is familiar with occurrence cubes. From the poll, we saw that a lot of people have already followed previous training sessions, but I'm still very briefly going to repeat what occurrence cubes are, so everyone is up to speed on that. This was also shown by Christina. So the B-Cube project aims to standardize and improve access to biodiversity data by aggregating. But what was not explained is why we do this, or why do we want occurrence cube? This is because there's a lot of biodiversity data available today, but they come from different data sources. For example, citizen science, but also research monitoring, automated things like acoustic monitoring, and all these different sources come together, for example, on websites like GBIF. And also these data sets do not always align properly in space and time. So that's why we want this aggregation in so-called data cubes. How do these occurrence cubes look like? So they were first developed in the TRIAS project, where they were used to calculate emerging trends of invasive alien species. And there they aggregated GBIF occurrence data taxonomically, for example, by species, spatially, by using a 1 kilometer grid, the European reference grid, and temporally, for example, by year. So just to briefly show you what is spatial aggregation or how that works. So an occurrence is actually a point in space, but it also has an uncertainty. So a radius of uncertainty around it. And we actually choose a random point within that radius and then designate it to a certain grid cell of an overlapping reference grid. And then you get something like this. This is an occurrence cube in a flat format where you have a number of occurrences n. I will get my pointer for you. So here, a number of occurrences n of a certain species in a certain grid cell in a certain year. And we also have a measure of coordinate uncertainty. So that's how occurrence cubes look like. And within the B-Cubed project, we wanted to have a reproducible and robust workflow to work with cubes, to generate them, to process them, then to analyze them, for example, in statistical modeling, but also for indicator calculation. And finally, to have a nice visualization and clear interpretation of the results. And therefore, we developed R packages. So we used R because this is widely used in data analysis, in statistical modeling, visualization, in ecology and biodiversity research. And to make sure that this is a user-friendly and harmonized framework, we developed the b3verse, which will actually group or collect all these relevant R packages for occurrence cubes into a coherent framework. So now I'm going to explain what it is, this b3verse, how it works, and which packages are included. In general, we now have 11 R packages included in the ecosystem, as well as one frictionless data package. What that is, I will explain that later on. And they are all maintained via an R Universe platform, which I will also explain in a couple of minutes. The idea is that all the packages work together in a coherent framework. So the output of one package can be used as the input of another. So you have, for example, on the left, data generation packages. Then you can process and explore the data. And afterwards, you can calculate indicators or start modeling. So it's very important that the maintainers cooperate together and that the packages are nicely interoperable. Before I dive into the specific packages, I want to show you how we set it up. What are the essential ingredients to set up such a framework of multiple packages? The first important thing was a shared software development guide. It is published here on the B-Cube documentation website, and I can suggest to have a look there. because it can also be useful for your institute or for your project, because it has the latest guidelines on software, mainly focusing on R. There are also some other nice things that you can look at. To show you an example, here are the guidelines on R analysis. So it says which directory structure you should use, which coding style you should use. We use the b3verse style, and which that you have to store your R code in R files or R Markdown files. But not only this, there's also information on R package development, metadata like citation files, etc., and also how to work in GitHub. We don't only have the software development guide, there is also a quality assessment within our project to see if people actually follow these guidelines. We were not punished if it was not perfect, but still it's good to have an incentive to follow the guidelines and to have a look within the project what the quality of our software is. And then I talked about GitHub before, so we used GitHub, which is very efficient for cooperation relating software together with other partners. And it also provides some automated checks. So for the people who are not familiar with GitHub, I can definitely recommend it if you need to work together on any code with people. As you can see, you can post here issues on other people, their repositories, or in your own repository. And you can add pull requests if you want to contribute something. And then within that pull request, you can have conversations with each other to see how you're going to implement it, if there's anything wrong, etc. You can ask for a review on your pull request if you want to create a new update of your software. And then these are some examples of automated checks that you have in GitHub that you can use. This is, for example, an update I wanted to do for my package. And you can see it automatically checks whether the code coverage of my unit tests is still good, but it will also test whether the package can be built on different operating systems. I created my package on Windows, but I want users that use macOS or Ubuntu also to be able to use my package. So GitHub will automatically check if it builds correctly. And very specifically, I even have a check, an automated check for spelling, control, and my coding style. As you can see, you can also have a setting that you require at least one reviewer before you update your software. A second thing that was very important for the b3verse is the development with our universe. So we have in our universe platform for b3. This is an open platform for running personal package repositories. So you probably know CRAN, which is a repository for the general R packages. But within our universe platform, you can create a repository for your own packages, for example, within your institute or for a project. The documentation is very clear, so you can have a look there if you're interested. This will create a searchable catalog for all your packages on one platform, so on one location. It will also centralize all the articles and datasets that are inside packages, which makes it very visible and accessible to people searching online. And it also simplifies installation of your packages. The nice thing is that it also all happens automatically. So it automatically updates and compiles your packages after you make changes to GitHub. And this is what it looks like. So this is our universe platform for b3, where we have all these b3verse packages. You can see the packages are listed here. You have a version number, the maintainers, any building errors on different platforms. So as you can see, we still have some stuff we need to fix. But this also happens automatically, and that's very, very nice. A third thing is a validation function central in the whole b3verse workflow. So for us, this is the process cube function of b3GBI, and that will actually process occurrence cubes data into a standardized format, which provides consistency and harmonization. So if you have an occurrence cube, you process it, and then all other packages that use it immediately have a validated and consistent data set as input, which also improves interoperability across the packages of our ecosystem. And finally, of course, visibility and outreach are important for packages. If we don't get feedback, we cannot improve our packages. We have the central documentation website of B3 that I showed before. And here, for example, it has a tutorial on the b3verse, which explains which packages are included, how can you install them, also how can you contribute to the b3verse, etc. But not only that, the tutorials that are on the package down websites of the packages themselves are also present here on the documentation website. As you can see on the left, for each package, they are available. So it's good to have like a central place to have all this documentation, which will improve the visibility for people searching online for packages, for tutorials, etc. This was actually not that easy. So we have a b3.r package that actually manages these markdown files from the original package down websites from the package and brings them to the documentation website. This is one of the b3verse packages. So here I already introduced the first one. And then, of course, training sessions and workshops like this are very important. So we hope that you will try our packages and have some feedback on it. Now I will go into the packages themselves and introduce them to you. So I categorize them into documentation. There are indicator workflow packages. Then there are two packages that work with statistical models. Some packages that are created also with other projects. And finally, we have a data package. So documentation. So this is this b3doc package that I introduced a couple of slides ago. This is used to create markdown pages for the b3 documentation website. So this is very specific. But for people interested in this, I suggest you can take a look. But this is very specific for the b3 project. What might be more interesting for you, for a broader audience, are these indicator workflow packages. So what does this mean, indicator workflow? So these are the packages that go from data generation, like RGBIF and Gcube, to data processing. So we have this process cube central function that I talked about, some data exploration, and then you have indicator calculation packages. So there's a workflow from data to indicator calculation as well as uncertainty calculation. We have several packages for that are nice and interoperable because of this gatekeeper function. So the first one is RGBIF. RGBIF is a general package that already existed before our project to search and retrieve data from GBIF. So you can download occurrences from GBIF, match taxon names with the GBIF taxonomic backbone, view dataset metadata. But now with the b3 project, we also made sure that you can download occurrence cubes with this package. And I will explain or show an example on how you do this a bit further on. Then we also have the Gcube package, which can be used to simulate occurrence cubes. So there are different possibilities. You can do Monte Carlo simulation, where you, for example, draw a number of occurrences from a Poisson distribution, and this can have a trend over time. This can be spatially clustered or randomly distributed. Then you can simulate the detection process, where you will decide whether you detect occurrences or not. And then finally, you have grid designation functions, where we have functions for that randomization that I showed before within the uncertainty circle. Other options are to create occurrence cubes for virtual species. And finally, you can also use the functions to do this random grid designation with your own data set. So if you don't have a data set on GBIF, but you have your own data set, you can use these functions to create a cube with random grid designation assignments. Now the indicator calculation functions. The first one is b3GBI. With this, package, you can calculate general biodiversity indicators for occurrence cubes. This is something Shawn will talk about in the second part of this presentation, so I will skip this for now. The PD indicator package can be used to calculate phylogenetic indicators for occurrence cubes. So you don't only need an occurrence cube, but you also need a phylogenetic tree and a spatial grid if you want to have a nice visualization. So what you can do is calculate phylogenetic diversity as the sum of the branch lengths. And you can see here on the right for the Phahalis, which is an order of plants, that you have a nice distribution of your phylogenetic diversity, which is calculated per grid cell. Another thing you can do with the package is add a spatial grid with protected areas and calculate the proportion of high phylogenetic diversity grid cells within protected areas. But of course, then you also need to set a cutoff value to decide when is it high, when is it not. The third one is the IMP indicator package that can calculate alien impact indicators for occurrence cubes. So here you have your cube, but you also have an ICAT assessment data set. This is an assessment of the impact of invasive species. So that can be massive impact, major impact, minor impact, etc. And with that data, you can calculate a site impact indicator, as you can see on the right. So for each grid cell, you get an impact value that can be aggregated over multiple species. And this aggregation, this is something, there are multiple options. You can set it yourself. But you get a nice map with the impact values. And then you also have an overall impact indicator where you aggregate also over the sites. So you get a value per year. And also here you can decide how the aggregation works. And it will also account for sampling effort. And then finally, there's also a species-specific impact indicator, which is the same as the previous one, but you can also have it per included species. Then we also have the DubiCube package. This package can be used for data exploration before you do any indicator calculation, but it can also be used for uncertainty calculation via bootstrapping for indicators. So it is actually present or can be used in the whole analysis pipeline from the beginning until the end. So in the beginning, you can download your occurrence cube with RGBIF and then process it with our gatekeeper function. And then you can use the functions of DubiCube to do some data exploration. On the left, for example, you can see some data quality diagnostics. So I run the DubiCube function on my cube, and you can see, for example, we get a very important message that there are a lot of records with a high coordinate uncertainty. So that might be an issue. And we also get a note that we only have 3 taxa in our cube. So then the user can decide, do I know I only have 3 taxa, or is this a problem? Did I expect more taxa in my cube? So these are data quality diagnostics. And afterwards, you can filter your data, for example, to not have big coordinate uncertainty, or you can make a new cube and go through this iterative step. Another data exploration tool is group level sensitivity analysis. So this is a group cross-validation technique where you can, for example, perform leave one species out cross-validation or leave any other group out, like years or grid cells. But here on the left, you see a leave one species out cross-validation. So each time you calculate your indicator by leaving out one species. And you see here for 2 species, if you leave them out, the indicator value is much lower than if they're included. And indeed, if you go look at this species, this was actually, in this case, it was because these are 2 species that are from a bird tracking data. So actually, they have a lot of occurrences in the cube, but they're often from the same individual that is just tracked every minute or every hour or so. So it has way too much observations, and it should be controlled, or you can decide maybe to leave this data set out. Further on in the workflow, if you're happy with your final data set, you can calculate an indicator with the packages I introduced before. And then you can use dbcube as well for bootstrapping. So you can calculate bootstrap confidence intervals. So you don't only have an estimate, but you also have uncertainty around your indicator value. You can use it on its own, but we are now also looking to implement it inside the packages. So you get immediately an uncertainty. And on the left, you can see an example of the bootstrap distribution with all different types of confidence intervals that you can calculate. And finally, dbcube also helps with reporting. It has an effect classification function where you use the confidence intervals and a reference value and thresholds to decide whether you have a significant increase, significant decrease. With the thresholds, you can also decide whether they are strong or moderate, or if the trend is uncertain, if the confidence interval is too wide. We also have tutorials on how you can best visualize uncertainty for temporal trends, but also for spatial trends in this package. Then there are two packages that work with a model-based framework. So the DisMapper package analyzes multi-site compositional dissimilarity, or the zeta diversity. But this was discussed in a previous training session, so I suggest you have a look at the training session of the 19th of March with Sandra, where this will be explained in much more detail. And also the next package has been the topic of a previous training session by Sandra. InvasiMapper estimates invasion fitness. So you can use it to decide whether species can successfully establish at a site based on the current community structure and the local environment conditions. But I suggest you also have a look at the previous training session to see how this package works. Then we have a couple of packages from other projects as well that work with cubes. So the EBV-cube package helps to access and visualize data cubes of essential biodiversity variables. And it works with data of EBVs via the netcdf format, and you can download data from the EBV data portal. These data that you can then download can you also visualize with the EBV data package, as you can see, for example, on the right for local bird diversity. Then we also have the Trias package. So that provided functionality for other projects like Trias and Live Riparias. An example is the trends that were calculated in Belgium for invasive species on the alien species portal. For example, on the right, this is a trend for this parakeet, which we now see a lot in Belgium. And then finally, the last member of the b3verse is a frictionless data package. It's called b3 data. Now, what is this frictionless? Frictionless data is actually an open source tool that is designed to make data more interoperable so that you can use it everywhere with different software tools much more easily. Because the problem is that data are often messy, or you have data, but the metadata is not provided. So you don't know where it comes from or how to cite it maybe. And it's often difficult to move between software tools. So this frictionless data standard tries to solve this. How does this look like? So a data package actually bundles the raw data, for example, CSV files, with their instruction manual. So this instruction manual is this metadata. It's called, for frictionless data, it's always called the data package JSON file, which is a machine readable file that describes the data, but also the origin and licenses associated with it. So for b3verse, we have the b3 data package, and it contains example data cubes and spatial reference grids, which are all version controlled on Zenodo and can be loaded directly into R. And this is one of the advantages that is so easy to load in R, but you can also load it in with Python or any other language. And I will just briefly show how you can do this in R, for example. So you load the frictionless R package, which is available on CRAN. And then you can read this data package JSON file from Zenodo with the read package function. And if you do that, you can see here, by the way, if you double click on my slides, it should be larger for you if this is not well visible. But you can see here that there are currently 2 data sets within our data package, a bird cube for Belgium, and also a reference grid for Belgium. So in the future, we will try to add more data within this data package. I accidentally clicked on it. So that was an overview of all the packages. I hope it was clear for you, but if you have any questions or if you want to contribute, you can always contact us on the GitHub repositories or via mail as well. Before we go over to indicator calculation, I want to show you how you can actually download data cubes with our GBIF. Because I think in the first training session, it was already introduced that you can now download occurrence cubes from the GBIF website. But there are some people who don't like to use their mouse and click on things. Some people want to program everything. So you can also download occurrence cubes from R. And this can be done with our GBIF package. What do you need for that? You need to have GBIF credentials. You need to have an SQL query, and you need to have a script with functions from the package. So these GBIF credentials, these are your GBIF username, your password, and your email. And the best way to do this is actually to store this in your R environment file. That way you don't have to put it in your script, because you don't want to put any passwords in your script in case you want to share it with colleagues or even put it on GitHub for everyone to see. But if you put it in your R environment file, it is only on your computer. So this is much safer. If you have any problems with this, you can always contact the help desk. Now this SQL query, there are some tutorials online that I can suggest, because you can do a lot of different things. But also the training session of the 24th of February explains these SQL queries. So I can definitely recommend to have a look at that training session if you're interested. But still, I'm just going to give an example so you all know what it looks like, such as a query. So the first part of the query actually selects, here you can select the dimensions of your occurrence cube. So here we want to have it per year, per species. We also want genus, family, and order information on the taxonomic level. And also the spatial level, which uses this function you can see on the left. So you have different functions for different reference grids. So here I use the MDRS grid on a 1 kilometer scale. Yeah, so that's your dimensions of your cube that you select. Then you also have some measurements that you can do. So for example, you count the number of observations per species, per grid cell, per year. You also calculate minimum coordinate uncertainty. You can calculate a higher taxon measurement. This can be used to, for example, to account for sampling effort in some cases. In this case, we calculate the number of observations per order. Then you also filter the data. So here we filter that we only want data from Belgium. We want data between 2007 and 2023. And we select the birds, so the class Aves. And also some filters are that we don't want any invalid data or null data. So you can also filter it out in this part. And then finally, at the end, you do the aggregation. You group by year, cell code, species, etc. And you can optionally also sort your data. So this SQL query, you can in R, in your script, you can put it between parentheses as a string. It's going to be a very long string. And then you can start your download on the GBIF servers using the RGBIF function occurrence download SQL. So here you can see you need to add your user ID, your password, your email, but you can do it like this using your R environment. So you see like this, your password is not going to be in your script, which is much safer. And the final argument is then your SQL query that you put in. There is a function occurrence download wait that shows you the status of your download, because it can take some time for your request to finish. And once this is finished, it will say that the download is succeeded. And then you can start retrieving the download to your local laptop. You use the occurrence download get and occurrence download import functions, and then you have your you get a file on your laptop and also in your R session, which you can see here. This is just a data frame or a table that you get with an occurrence cube. This is just a small disclaimer that I didn't use the same query as above, but the ID, it's the same ID behind it. So now I give the floor to Shawn, who will talk a bit more about the B3 GBI package.
So I'm going to share my screen now. All right, so I'm going to talk briefly about the highlights of the B3 GBI R package, and then I'm going to spend most of the time doing a hands-on demonstration of how to actually use it.
I don't see your slide, Shawn. It's again this.
It's paused. Let me see.
Or is this only from my side?
No, I think it says it's paused. I just have to figure out why that is. Let's see. Okay, that should be working now.
Yes.
All right. So I'm just going to spend a few minutes quickly highlighting the b3 GBI R package, and then I will give a hands-on demonstration after a short break, and most of the time will be spent on that. So primarily the b3 GBI package is designed from the ground up to be user-friendly and to be very simple on the front end while complex on the back end. So it's handling everything behind the scenes essentially. So it's hopefully very easy to use. So it has a 3-step process essentially. So the first step is that you have to ingest the cube and prepare it for use by the package. And this uses the process cube function, which Wout has already mentioned. So you need an existing cube, which you get from either GBIF's website or the GBIF package, or a simulated cube that you can make using Wout's gcube package. So this takes care of formatting everything into the right standardization. And then the next step is to actually calculate your indicator. This is very straightforward. There are 18 different metrics currently available in the package, with more likely to come because it has a modular design where we can add more indicators without actually messing with the core code. So it calculates currently uncertainty during the calculation of the indicator by bootstrapping the indicator calculation. This is going to change at some point, and we will use the dubcube package on the back end to bootstrap the entire cube, which is mathematically more robust. It's also slower, so I will retain the option to use the bootstrapping at the indicator level for those that want to, and that will be coming probably in the next couple of weeks. But you can calculate metrics over time or space, and then you make your plot. So it's just 3 steps, 3 functions, very simple, very quick, and you can generate very nice plots. And so this is an example of a time series plot with not really any changes made to it. This is how it comes out. It's integrated with ggplot, so that's what's handling the backend for the plotting, and you can add your own custom ggplot code to it if you're not satisfied with the options. It's using R natural earth data for the mapping, and so you can use any of the built-in naming conventions for R natural earth to determine the specifics of your map, and you can also use the layers that are available from our natural earth. When you're generating plots of individual species, you can automatically combine them into a single plot. You can also add your own shapefiles to be very specific about the area of your plot, especially if you're using a small research area. And there's also available map view integration. So map view is using Leaflet to generate interactive plots, which you can zoom in and out. You can change which map layer you're using with a single click. It's not so nice for making plots, but very convenient for actually interacting with your data plot. So it's also quite powerful. It supports 4 different grid systems, which you can download from your cubes from in GBIF. The military grid reference system, the extended quarter degree system, the EEA grid reference, and just recently was added the icosahedral equal area hexagonal grids. They're not well tested yet, but they are in there. You can use any coordinate reference system for making your plot as long as it's compatible. And there is also a Shiny graphical user interface available, which is online. It is quite outdated at the moment. I'm working on a big update, which will bring it up to date with b3GBI, which is running the back end of the package. It does work at the moment, but it's using an outdated version. So hopefully soon there will be a newer version available. And we'll now take a 5-minute break. And when we come back, then I will walk you through how to actually use the package. So maybe in the meantime, you can go to the website here, which is my GitHub repo, contains the files that you'll need. It also has an HTML walkthrough of the demonstration. So if you don't want to actually, follow on along by doing stuff, you can just look on the HTML, or you can watch on my screen. It's up to you. But now would be a good time maybe to have a look on that. So I'll be back in a few minutes, 5 minutes maybe, and then we will start. All right, I'm stopping sharing the slides now, and I'm going to share my R screen. All right, hopefully everyone can see it. So before we actually start, the first thing is to make sure you've actually got your demo on your computer and into your working directory. So you can either do this in your RStudio terminal. You can type git clone https github.com/shawndove/b3gbi-demo, and then you can either name a folder, or you can just leave that out and it will install into the folder using that name. Alternatively, you can just go to the website and download the files and put them into your working directory. And then in your console, you can type getwd with parentheses, and that will show you what your working directory actually is. And if it's not what you want it to be, you can use, okay, I'm not getting access to it. In any case, you can use setwd and set it to the working directory that you want. So anyways, you have two options. You can view it as source, or you can view it in the visual mode. You can also use the HTML if you prefer and just see the already done results.
Shawn, sorry
Yes.
to interrupt. We cannot see your console because you have like a small black box in there on the left. I don't know if that's something you can remove somehow.
I will try.
I think you should
Does
be
it
able to
work
hide
now?
meeting controls of the Zoom session somewhere. Oh yeah, now it's gone. Yeah,
Okay, I moved it to the other side.
yes.
That was why I couldn't access the console. Okay. So in order to follow along, you have these little green triangles in the Markdown file. Whether you're on source or visual, you have the green triangles. And you just click on one and it will automatically run the code. So it's going to take maybe 25, 30 minutes maximum. And the first thing we want to do is make sure you have b3GBI actually installed. So the code for it is right here. You just need to click on this green triangle and wait a couple of minutes and it should download and install it. If you do have any problems, you can always just watch my screen or switch to the HTML version, which is already knitted together with the results. Then we need the libraries. So we have b3GBI, and also I'm using a little bit of dplayer and ggplot2 code. So we'll load that up. I'm not doing the install because I already have it installed. Okay, so there are example cubes already within b3GBI, and we're going to start with one of those. There are some that are already processed, like indicators and cubes that are just as data objects in there. But in order to show you process cube, I'm going to use a CSV file, which is also included. So we need to set up the path for that. And we use this system.file, which will find the path, even though you can't see it yourself. And you put in this ext data because that is the directory. And then the name here. and then the package, and it will find it. So you make your cube path, and then we run it through process cube. In this case, we're going to make the data from 1990 until 2020, just because it's a cube of Denmark and it actually starts in the 1800s sometime, and that's just going to make the plot harder to read when we do a time series. Okay, so that's already processed, and now we can have a look at what it looks like. So this is using R's S3 object-oriented programming system to have a custom object with, in this case, metadata included. So it doesn't look quite like this normally in R. It's just giving us this nice visual where it separates the data table from the metadata. Normally they're together and you just see the first 10 rows of the table. But anyway, you can see what the object is, the date range, what the resolution of your cube is, its quarter degree, how many cells you have, the grid system, which is quarter degree grids. Coordinate reference in this case is lat long. It's not going to be like that for other grid systems, but this one at least is easy to read. How many observations you have, number of species, number of families, what kingdoms you have. In this case, it's a cube of Denmark mammals. So we have Animalia. And then normally you would see here the first rows of data, and it's set up as a tibble. So you can just use print and then n equals to show how many rows you want. But here we can actually see it in a nice little table. We have the most important columns are the year, the cell code, and either the taxon key or scientific name. And then normally you have a column called something like occurrences. And these all are necessary in order to make process your cube. And it renames the columns to what it wants to standardize things. Usually you have an uncertainty in there as well. And your other columns are usually left alone unless it's something like year month, in which case it will turn it into a year column because it's not using that kind of granularity for calculating indicators. It's only using years. So, and then it will give you out also this X coord and Y coord and resolution columns, which you need in order to calculate your indicators and also probably for other packages. So everything in Process Cube is handled basically on the back end. You can give it specific column names if you have weird ones for whatever reason, but normally it recognizes them. It will recognize what grid system you have, but you can tell it if it doesn't. And it will take care of translating the grids and everything. So yeah, if we actually print it, then it looks like this. And we've said 30 rows here. So your data is accessible as a data object within your cube. So if you can see in the console, if you type Denmark cube data, then you can actually see just the data without the metadata, and you can access it. Okay. So now we want to calculate, starting with a time series. We'll just do a trend of total occurrences because it's nice and simple. And it will automatically do the bootstrapping, but we'll set it just to a low number of bootstraps of 100 because we want to make it quick. Confidence interval type, we have at %. And this calculates very quickly. And then we have our object and we can look at it. So again, we're getting this nice view similar to the process cube. The object is very similar with your metadata. The table contains years, diversity values, that's your number of occurrences, your indicator, or so your confidence interval type, your lower and upper bounds, and your confidence level. And not everything is going to have a confidence interval calculation because some indicators like observed richness, for example, we cannot calculate that because it doesn't actually make sense. You can't get an upper bound that is higher than your observed number of species by bootstrapping. So if you're estimating your richness, that's different, which you can do using the INEX package within b3GBI. It has an indicator for that. But for just observed richness and some of the others, you cannot get reasonable confidence intervals. So now we plot our indicator. We'll just see the basic plot first. And we get something like this. It's already got a title, which you can modify. It's got the titles on the axes, and it's got your data points here in orange with your confidence intervals, and then you have a smooth trend. And you can turn that on or off. You can change all the colors and things. So let's say that we want to have a plot that's more tuned for people with that can't see so well. So then we're just going to modify the min and max here just for fun, because show you how to do it. We can change our title, our labels, our colors, and we can change the thickness of everything. And this Y expand is just to make a little bit more room around the data in our plot. You can also do X expand. So then we get something quite different because we changed all the colors, a little bit the opposite. We changed our thicknesses and whatnot. But you notice we still have our values in our axes are still quite small. We don't have options directly to alter that. You can see what options we do have. So this is using plot_TS. And so if you type help, then it will show you all the options that are available along with explanations. So if we want to change those other things, we can just add a little bit of ggplot2 code, and away you go. We change the theme, we change the sizes. So if you know ggplot2, then it's very easy. All right, so now let's have a look at maps. So we're going to have a look again at the total occurrences so that we can see how it's distributed in space. We don't have a way to calculate confidence intervals on maps because we don't have a way to visualize them at this point. It will hopefully come at some point. So when you're doing a map, it's best, if you know the region that you're working with, that you select that region because you will get a better map and it will take a lot less time to calculate because it doesn't have to grid over the entire bounding box of the cube. In this case, we're not including the ocean just because it's, again, quicker and maybe looks a little bit nicer. And so now in the plot, we're adding crop by region because this will center Denmark within the center of the plot. And so then you get something like this. But now we're going to move on to something a bit more interesting that we can actually do some data exploration. Again, if you want to see the options you can use, you type plot_map with a question mark, and you get then your list of available options and explanations. Okay, so now we're going to use the Ramsar cube that we included. So Ramsar is a wetlands convention. It's wetland sites that are globally important for biodiversity and whatever else. And I chose a somewhat random site from India because it has a decent amount of data in it, which is unusual for Ramsar, and it's distributed fairly well over the cells. And so we start by just processing the cube. Done. We can have a look at the metadata, and we see the data is from 1990, so it's fairly recent. Is 100 square meter cell size with 177 grid cells. We have coordinate range, which doesn't probably look recognizable because it's MDRS. We don't have lat long this time. So the military reference system is related to UTM. And we have 539 observations. of 188 species. So we have a very high relative richness here, representing 61 families. And it's an Animalia. And we can have a look more closely what's actually in there. I actually put a function in the package to do this, but it's not showing up yet. So I'm just using dplayer code. It's just calculating the total number of observation across whichever rank you choose, in this case, classes. And we see we only have birds in here. So 539 bird observations, which is kind of making sense because it's a Ramsar site, so it's wetlands. Now we can list species. This is again the function in the package. We'll just show you what's in there. A whole list of the species doesn't maybe mean anything to most of you and also not to me, but it's just to show you what you can do. So we want to do some analysis. So let's see what tools do we have available. So we type available underscore indicators. And this is actually a data object, which will show you all of the indicators that are in the package. They're all registered in there, and it tells you how to access them. It tells you that the classes and any additional arguments that you need to worry about, which in the most case, they don't have any special ones, but there are some that do. So we have 18 indicators here, and you can see here, for example, these hill diversity, which are calculated by the iNext package. They have cutoff length and coverage, which you need to care about, whereas most of the rest have no extra arguments. So we're going to keep things fairly basic here. So we're going to plot total occurrences again to start. And we're just going to do the basic plot because we have a very small area we're working with. We don't have to worry about a big grid. If we select a particular region here, it would be India, and then we'd calculate a 100-meter grid over all of India, which would take probably hours. So we're not going to do that. And then we make our plot. And right now it doesn't look like much. We just have some occurrences values sprinkled around and a gray background. Since it's a very small site, we don't get much out of this, and we don't see any features. So we add in a shapefile now, which will show us what the boundaries of our data actually are. So this is the official Ramsar shapefile for this site. And then we have not bothered to specify a CRS for the shapefile. If yours is in the standard one, which is EPSG 4326, you don't have to, it will make the assumption. If it's not, then you should specify it with shapefile underscore CRS, just like this. For us, it makes no difference now. And then we make our plot. And now you can already see that you have a nice boundary line showing where your data actually should be. And the data looks reasonably well distributed. There's nothing crazy going on here. And it's quite a bit of data comparatively for such a site. And you can see that it's a very small area. It's only covering, 0.025 of a degree, something like that. So very small. So we can make this even clearer. So we can add visible grid outline and give it a color, and we give it a width. And then we turn off cropping to the grid because then we'll get a little bit of extra space around just to make it look nicer. And so now we can clearly see where our boundaries are. So, but it's just still a plain gray background in the middle of nowhere. So at this point, we could try to add additional features if there are any. So because we have our natural earth layers, but I'm not going to do that because right now the layer downloading is broken. It's not working, and I have to fix it. But it's expected to be at a wetland, so you would think there's some kind of water feature there. So what we're going to do instead is we use plot MV, And now we can have an interactive map and see what things are actually looking like here. And we see we do indeed have a water feature here. And our data is exactly where you would expect it to be. We can change our background here. So we use world imagery. And then if we zoom out, so this is coming from a web server, the data. It's not on our computer. We can see that we are indeed in the middle of India. Just a little tiny space in the middle of India. Yeah, so that gives us a way to explore a little bit what the surroundings are like. So now let's make another plot, and this time we're going to do the observed richness. So we first do our calculation, and then we plot it. We don't actually need, so this scale equals large is just telling to use the most high definition data they have from our natural Earth. We don't need it for this because we have no features to see actually. So what we notice is this looks pretty much the same as our previous map that we calculated, which is a bit strange because now it's richness and not total occurrences. So let's see what's going on here. We look at them together. And now we can go back and forth. In fact, they're not similar. They are identical in every way. And yet they are different things that we're plotting. And my first thought seeing that was, okay, something's wrong with the package, but actually not. So why would this be occurring? Well, let's have a look. So we'll again check that we have the right number of species and occurrences. Yes, we have 188 species and 539 occurrences. So there are more occurrences than species, about 3 times more. But that doesn't really explain why we get identical plots. So we checked that we haven't lost any data by summing our actual diversity value over all of the cells. And yes, we still have 539. Everything is there. So let's group our data and make a sum of our observations. And then so we're grouping it by year, by cell code, and by taxon key. And this will tell us whether or not we have more than one species appearing in the same place. More than one individual from the same species appearing in the same place at the same time. And if we do, we should expect that the maps would not be identical. If we don't, then they can be indeed identical. And we see that this is indeed the case. So the identical maps are to be expected. And we just double check that we have all individual rows here. And yes, we have 539, which we're expecting. So every single row is an individual observation. So it's really the case that no single species was found in the same place twice, which is basically saying that they have really poor surveying of the site and a really high richness. So we can actually measure the sample coverage with the completeness indicator, but I suspect that with such a low amount of data, we will not get a very reasonable result. But anyway, over time, it looks like this. I think these high values are way too high because it's just too small of a sample to estimate properly. And most of them, though, are very low, which we would expect. And if we average across the years, we take a mean, it's 0.2, which is a very low sample coverage. So clearly with such a high number of species, they should be sampling much more. But of course, anywhere outside of Europe, this is pretty common. But for Ramsar site in particular, this is considered to be a very high density of occurrences because I've actually been working on a project looking at Ramsar sites and most of them are much, much lower than this. But okay, so we're calculating density here and we see these messages are just because we can't get confidence intervals because there's not enough data for most of the years, but it's still calculating. So now we plot our occurrence density and take a mean, or sum, sorry, and you see that we have 72 occurrences on our data set per square kilometer. Now, there was some research recently where they were looking at, I think, North American data that's from GBIF and other similar places to try to get an idea of what you need for a reasonable trend recognition. And they came up with 0.25 observations per kilometer. So we have way, way, way more than that. However, they also had other things they were checking. For example, the SAC slope, which is the inverse of the completeness indicator we have, and that should have been 0.1. And then we would expect a 0.9 for our completeness, and instead we got 0.2. So you can see that looking at just one thing doesn't tell you very much. Actually, this is not nearly enough data to tell us anything about the trends. So in fact, our trends are entirely controlled by the sampling effort, and we have no idea what the sampling effort is because we don't have a good measure for this, which is a big problem now, and that's being discussed in many fields, I think. And we also don't have an answer, especially for open data like GBIF. So I'm gonna end this here now, and I'm gonna give it to Jasmijn, who is going to tell you about some real-world results that she got in her own project.
Yeah. Hello. Normally I'm sharing my screen, but you can correct me if it's not the case. And you also hear me, I hope.
We can see and hear you.
That's perfect. So for now, I will shortly illustrate how I explored the b3verse universe for Flanders. So the goal of my goal in the project of B-Cubed is to test the B-Cubed workflow for Flanders, and Flanders is an area which is very rich of species occurrence data. So there is a lot of data available of Flanders on GBIF, and we want to test the workflows, create indicators, create a dashboard as well. But we mainly hope to encourage other dashboards that are have a long-lasting persistence to also showcase our indicators and include the workflow of B-Cubed so that they are more effective afterwards. And on the right, you see different examples of dashboards which are already existing and who we are in touch with to include the indicators that we are testing. So the different packages that I tested were b3GBI to create general biodiversity indicators, and PD indicator to test phylogenetic indicator, Trias and b3alien for the invasive alien species indicators. And this is how the dashboard looks like at the moment, but it's still under development. But if you want to have a look, you can visit the website. And now I will go more into detail to some interesting indicators that I checked. For instance, when I tried out general indicators from the package b3GBI, and I checked the trend of occupancy of flowers over time, there were some interesting trends. For instance, this species, Centaurea cyanus, is known to be dependent on grain fields, but as the use of herbicides was very intensive around this period, 1975, 1980, herbicides became more popular, and then the species has decreased and became quite rare in Flanders. But now, more recently, there were management plans by by some parties in Flanders, and they created seed mixes including this flower, but it were certain cultivars, unfortunately. But this explains the sudden rise the last years that we see of this species. Then another example a bit similar is Arnoceris minima. This is also a species depending on grain fields, and we also observe for this species a decrease in occupancy over time due to the use of intensive herbicides in Flanders. And then just to show an opposite trend, this species b3verse Ophrys apifera is increasing over time due to climate change, because conditions become more suitable due to climate change, and that's why we see over time a sudden increase of the species in Flanders. And the data that I used to create these indicators are FloraBank. FloraBank is a data source of INBO, and it is really also collected by our the people of INBO, and we invest a lot of time of putting all our data openly available on GBIF, and that's how I could check this indicator. Then except for species occupancy trends over time, I also have tested other indicators from the package b3GBI at the community level, for instance, observed species richness. At the dunes, this is, for instance, an area that is known for high richness, and that's also lighting up in the map. And we also test other packages like PD indicator with phylogenetic diversity. So the difference between the two maps is that phylogenetic diversity is including the phylogenetic distance between species at a certain area, and the larger the phylogenetic difference, the higher the phylogenetic diversity. Then one of the indicator packages that we are also testing are the TRIAS packages. And as Zwart already mentioned, and a very important indicator from the TRIAS package is the emerging status. And if you are interested in the emerging status of several alien species in Flanders, you can visit the alien species portal. There, these are already available. And this is an overview of all indicators that were developed within TRIAS, and they are all available at the alien species portal. Then eventually, I also used a b3 alien package developed by Maarten to calculate the target 6 indicator for Flanders and Belgium. And I hereby refer to the session that in which Maarten explained his package. So if you click here on the bottom right, you can have a more detailed talk of Maarten. But now I will just show the results. And for Flanders, we have a best case scenario of the rate of establishment of invasive species in Flanders. And we also have a worst case scenario. And the data that I'm showing now are based on the risk checklist. And the best case scenario is taking all, not all species of the risk checklist in account, but is filtering based on the degree of establishment. So only species which are established or invasive or widespread invasive are included as newly established. And then here we have higher numbers as we include more species of the risk checklist in our analysis, and we are not strict on this parameter degree of establishment. Then I will also include 2 more indicators in the dashboard, which I'm still developing. And one extra indicator is comparing occupancy between 2 periods, the baseline periods and the future periods. And this is a very important indicator because it's already used by member states for reporting to the European Union. And you can already visit the alien species portal if you want to explore some of this indicator for species of Flanders. And then there's also one other indicator that's often used by INBO, by my institute, and that is for at the level of Flanders. We are always reporting the percentage of alien plant species over time. And if you, this is very important. It's also, one of the standard indicators that is used. It is already displayed on this link, but now I'm turning it into a B-cubed workflow as well. Thank you for listening.
Thank you, Jasmine. Thank you, Ward. Thank you, Shawn. Thank you for taking the time to introduce us to the b3verse and for showcasing all these examples and providing all these useful materials. There are still, sorry, let me just quickly share my screen. Okay. So more useful information is available on the B-Cubed website under guides and tutorials. So please do check that page out. And as mentioned already, the trainers today gave us a sneak peek on what is currently a work in progress by the B-Cubed team. There are 4 case studies that are being developed just to showcase the utility, the usefulness of the B-Cubed outputs. So they are focused on different topics, either Ramsar sites or biological invasions or the Habitats Directive and reporting, and at different spatial contexts, so either national or regional, continental. So please do keep an eye out on what is happening in the B-Cubed project. For that, you can just have a look at the website and at all the social media platforms that we are active on. You can always sign up for the B-Cubed newsletter. And you can always also write to us on info@bcube.eu. There were some questions in the chat about the certificates of attendance. They are available upon request. So send us an email using this address and they will be provided. Also, if you find yourselves missing us next Friday, just say hello at this address and we'll be happy to hear from you. I think that's it from us. Thank you again to all the speakers, to all the B-Cube team that made this training series possible, and to all the participants that joined in. And hopefully they learned something and spent a nice afternoon together with us. Enjoy your weekend and see you sometime.